Chapter 5, Section 3, Factoring Trinomials of the type ax squared plus bx plus c. So the difference here in factoring is we have this coefficient, or a number times our first term. And that can increase the amount of possibilities we need to check. So the first thing they go through again is FOIL. What that means, which is first times first, outer times outer, inner times inner, last times last, as a method of distributing this multiplication between two binomials. So they show that here and how that would work. Here we got 2x times 3x is first times first, you get 6x squared. Then outer is 2x times 4, which is 8x. Right here is your outer multiplication. And inner is 5 times 3x is your 15x. And last times last is 5 times 4, 20. And then we combine those like terms and we end up with that trinomial. Well, when we're looking at anti-FOIL, we're basically, let's look at that in reverse. Well, to get the first term of 6x squared, I look at factors, or things I can multiply together to get 6x squared. And the product of the outer terms plus the product of the inner terms, that inner one, and then we have that product of the last terms. In other words, they go through FOIL, right? Now we can do such factorizations like this in this kind of a strategy. We know we're going to have an x times x to get the x squared. Now we might have options of different factors that can multiply together to get this a. And the last we look at, probably next, we look at the last part of FOIL, which is the L, this times this, and we'll get this C. So we're looking at factors of this number here. And then we got to check to make sure my inner and outers work. So we take factors of the first terms of the binomials and create first terms for the binomials, and then the last term we take factors of, which will be our second terms in our binomials. And then we check, really. We check and say, if I did this multiplication, which would be outer times outer plus inner times inner, will these things add together right to get that middle term correct? So there's our strategy, and let's go through some examples here. And the first one here is factor 3x squared minus 10x plus 8, and I see so many errors around negatives and sign issues. So remember, when they're talking about terms, they're really talking about parts of an addition. That's the definition of a term. So this term is really 3x squared. This term right here is negative 10x, and this term is negative 8. Okay? I think if you think in terms of addition, it's going to help you make less errors. So just a reminder about that. So let's go through these steps that they take us through to factor this. It says first check the common for a common factor. Boy, do not miss this. You can make your factoring be a lot more complex if you miss a common factor. And what that means again is I'm looking for these terms here again. Is there anything common that I can factor out of each one of these? And here I have 3 as prime, so factors of 3 are 1 and 3, and x squared are x and x. 10 is factors of 10 are 1, 10, 2, and 5. They don't match with anything there. And x, there is an x, but it's got to be in all 3 terms for us to be able to get a common factor out. Prime factor 8, you get 2 times 2 times 2, right? 2 is a factor 3 times, okay? Well, in other words, I've just checked. There's no common factors. I like doing prime factorization. You will not miss anything if you do it that way. Okay, so that is checked off. And then they do mention this negative 1. We'll get into some examples where working with negatives and factoring out negatives can do some real strategic things to help us take a lot less steps to solve things. So we'll keep that in mind, that -1 stuff.
I couldn't find Saul.
How many times I gotta turn this damn thing down? Bye. So after we've checked that, then we start looking at that first term. Well, 3 is prime, which cuts down the possibilities for first term issues to look for. So, and which is, we got 1 and 3. Remember what they showed us here is you put the x and x. The only way I'm going to get this x squared is take x times x. So I know that this splits these two factors here this way. And then I'm looking for the coefficients of those. Well, the only factors of 3 are 1 and 3, so one's going to be 3 and the other one is 1. Okay. Then we look at factors of the last term. Remember, we're talking about a -8, and this is positive, which is handy, makes this both positive, right? We also can make them both negative, but we'll, like I said, we'll talk about how you can manipulate that to make it more simple. To do that, we can always factor out -1s to change signs of anything. So, well, now we need factors of -8 that we're going to put in here. And all the factors of -8 are listed here. We got -1, 8, 1 and -8, 2, -2 and 4, and 2 and 4. Now, notice that they list these twice here because they can be in a different order, and order makes a difference because of this coefficient here. Before, it really didn't matter where I put this other than I had to deal with sign issues. And now it really does. So we could use, what this means in this order would be 3x plus a -1 times the quantity x plus 8. Compared to this one, which is 3x plus 8 times the quantity x plus -1. And if you do those two multiplications, even though they involve the same factors, you're going to get a different middle term. Okay. So they go through this, and then, so now I have basically all the combinations of this that I can deal with, which is quite a few. And that's what they show us here in this next portion here, is if I use the factors -1, 8, just like I said before, I'd get 3x minus 1, or plus a -1, times quantity 8 plus x. If I multiply that out, I end up with 23x. Now, every one of these multiplications, the first term and the last term, should be correct, right? We're really just listing these out to check that middle term. And I'm sure you're going to find some shortcuts to having to list all this stuff out as you're going. But it does take some organization. Don't give up your use of paper just to you're trying to save a bunch of paper and then write this in a way that it's easy to get lost in the middle of this. I think, especially when we're dealing with problems that take several steps to work, if the real world is you got distractions going on all the time. So get organized, write your stuff down, so if you get distracted, you don't have to start over every time. It might take you several minutes to get to this point. But that's what they're doing here too. And they'll say later on, typically, as you're testing and you're going through these combinations of factors for these binomials, once you find that middle term, you're going to stop. They basically listed the rest out just to show that, there are a lot of possibilities that occur, even when this first term is prime, in a sense, or the coefficient's prime. So they find out by experimenting to find what the middle term result will be, the inner and the outer added together, right, or outer inner to put in the right order. They figure out that this is the actual factors that will give us our original trinomial. Okay, and that's where they take in here. They say, each trial will differ in the middle term. Only the sign in the middle term seems to change when the signs of the binomials are reversed, and so on. So they're basically saying that, you know, you could reverse signs, you're going to end up with probably the same amount of steps to find the factoring. So let's this example 2. Now we have 10x squared as the first term. So now it gets a little more complex, not more complicated, just basically more combinations. Now this case here, the 7 is prime, which means there's only 2 possibilities for to get a positive 7, or actually 4 factors really when you deal with negatives. But there's a lot more options for this first term. So they consider that. Again, look for common factors right away. I want to make sure if I have, you know, this is 2 times 5, 37 is that prime? I think it is, and 7 is prime. They have no common factors, okay? Or another way to do this quickly is this is 2 and 5. How do I know if something has a factor of 2? Well, it has to be even, and neither one of these are even, so 2's out the door. And factors of 5 means that either the ones place is 0 or 5, and I can very quickly say, well, 5 doesn't go any, then I'm done. You know, I don't have to go check everything. You know, look for the ways to make this easier. Okay. Well, there's 2 possibilities for first terms in this binomials. I could have 10x times 1x or 5x times 2x. And the factors for the last term. So after we check for common factor, then we deal with how can I write factors to get my first term. And that's this 10x times 1x and 5x times 2x. Next we look at the last term, which is 7, positive 7. Well, it could be 1 times 7 or negative 1 times 7. Now order matters, right? So you actually have these other 2 possibilities because, you know, how we put it into this deal. Now we end up with a lot. If you listed all these out, that means that there's 4 of these and 4 of these possible. So you have 8 possibilities to write out, and then you basically put them in, figure out what your middle term will end up to be, and when you match this 37x, hey, you got it. Okay. Now let's go through this one because this one has a common factor, and this would be you know, if you think about all the combinations that can happen here, if I miss a common factor, I have a lot of combinations of getting 24. You know, I can have 1 times 24 or 1x times 24x, and then I got this x cubed thing. You know, that's a pretty good indicator. I can't even factor this into binomials the way it is and so on. But look for that common factor first and do that. Let's take a little time. I'm going to run through an example like this, and we can step through the help me solve it that happens as help during your homework, and also show us another example too. Okay, I just paused a little bit my screen might have moved quickly there, but to load this example. Here we have a trinomial. It says factor this completely. And you know, here's your answer blank. I could do it all on scratch paper. But let's do this help me solve this thing. And it says before factoring any trinomial, the first step is to arrange the terms in descending order if necessary. In other words, look at the degree of the terms. This is the 3rd degree, 2nd degree, 1st degree. So you put them in that order. That's going to help us later as organizing our work for for FOIL stuff. And then, so that's what they're asking. Is this in descending order? Does the degree go from highest to lowest? And the answer is yes. One of the reasons I do like this too is it does force some language on you. You know, like what is descending order? We haven't talked about that in a while, or you may have not paid attention to that to get your assignments done. Then it says the terms are in the correct order, so proceed to the next step. So I hit continue. And then it says factor out the largest common factor for this, and it gives us a pretty good clue. This is the result, right? So in here I have 3 and c times c times c. I have 2 times 2 times 2 times c times c and 5 times c. Well, the only common factor of all 3 of these terms is c. So we put c there, and we'll check that. And I like those little signs that come up. It says now notice that the expression inside the parentheses is in the form of this ax squared plus bx plus c, just what we're talking about in this lesson. So all we've done is take a common factor out, and then we're going to try to use anti-FOIL or the FOIL method in reverse to factor the rest of this. Now they always talk about a common thing is you got to remember that whatever I do to this trinomial now, I still have c times the entire thing because we factored out that c. So don't forget that common factor. So it says now we're going to look at this and say to factor, use trial and error method. This procedure, the FOIL method in reverse, may yield 2 binomial factors. Okay. The first terms of the binomials are the products, or the product, which means answer to a multiplication. Factors are parts of the multiplication, equal to the first term of the trinomial, which is going to be 3c squared. Well, what is a possible factorization of this? In other words, what out of this method, or these 4 examples, which one of these could result in me getting 3c squared? Well, in other words, is 6c times c, will that equal? No, that'd be 6c squared. This is 2 times, or 3 times 2 is 6. This is 6c squared if I did it. And this one will result in that. So just basically a little multiple choice to say, remember what factors really are. And this is a product answer to that multiplication. Next, we want to find 2 numbers whose product of the trinomial's last term, 5. Since the product is a positive number, the sign of each of the last term must be the same. In other words, I could have negative 1 times negative 5, or I could have 1 times 5. Well, in this case, they already give us 5, so the other one would have to be 1. That's the only number, 5 is prime. So I can get 5 times 1 to get 5. It says now check the combinations of factors for the outside and inside terms. In other words, we want this middle part here, this 8c squared, 8c really, because we took out the common c, is I want that inner and outers to add up to 8c. And that's what they start checking. So if I had figured out that I'm going to use combinations to do this, and end up with 3c plus 5, the next term in here, well, first of all, I know what to get c squared, I have to have a c, right? And I used a positive 5, so I'm going to have a positive 1. Just checking first my first terms and my, to get my first term right and my last term right. If they give me 3c and 5 already, I know this one has to be c and 1. Now they're kind of jumping to some stuff and missing this so that you don't have to write a lot of things down. Like we probably would have had a different, list a couple combinations to do that. But that really is the steps to go through. So the complete factorization of 3c cubed plus 8c squared plus 5c is c times, well, that's what we took the common factor c out, times the quantity 3c plus 5 times the quantity c plus 1. Now I would multiply that all back after doing a lot of work. I want to check, and it's usually easier to multiply and check to make sure you get back to the original polynomial. So going through these examples and that helped me solve this is a very valuable tool, and I hope you're all using that. And the other one in there too, which isn't shown there, if you get stuck on something, you can hit Ask My Instructor, and it'll send the exact problem you're working on to me so I can help you with that. So this one's finishing that example, going through all these possibilities again. You're probably going to use some significant amount of paper during these lessons, and so make sure you have some paper, some room on your scratch paper. Now here's some tips. This is really some stuff kind of pointing out, if you did 1,000 of these things, you're going to start seeing some patterns and stuff like that. So they did that for us, and they're going to point to some things that might speed up your work, maybe save a step or two, which is a good thing because it saves you a chance for error. So make sure that any common factor is factored out. We've talked about that quite a bit. And they're talking about here too, they made a restriction on this, though we could change the sign of anything. They're saying if this is positive, we can use these tips. So in other words, I could always make the first term positive by factoring out a -1 if I want to. So these tips could work in all cases. And it isn't contingent on this being positive for every one of these tips, but just a few of them they talk about. Okay. Next thing, it says once the largest common factor has been factored out of the original trinomial, no binomial factor can contain a common factor other than 1 or -1. Okay? In other words, if you did that right, that's what you should end up with. Then it says if c is positive, that's that last term, then the sign in both the binomial factors must match the sign of b. In other words, kind of a shortcut on FOIL again. If I'm going to have this is positive and this is positive, and this is going to end up being positive, which can save some stuff. If reversing the signs in the binomial reverses the sign of the middle term in the of the product, okay, this sign issue again. So what they're pointing out is you're going to end up with a -1 times a -1, which is really 1. So messing around with these signs is kind of futile when you get into the binomials like this. So we can change some stuff up front and stay within this. The other tip is to organize your work so you can keep track of which possibility you have checked. That's a big deal. Write down your work, put the parentheses around them or something. If you got to skip that, and make sure if you shorthand any of this, you know exactly what your work means. Okay. And remember to include the largest common factor when you multiply back or show your factorization. And then always do this. Check by multiplying. Make sure you just didn't do some simple area after doing, several minutes of work. I'd hate to have the wrong answer just because I accidentally changed a variable or something. Okay? So here's another example of 10x squared plus 8 minus 3x squared. Now, what's the first strategy we talked about in that example we talked about before they actually talked about it here, is put it in descending order of the terms of the polynomial. So this is first degree, 0 degree, second degree. So it should go second 1, 2, 1, 0 degrees of the terms. That's what they mean by putting them in the descending order. Now we can do that because of the commutative law. And then because the first term is negative, we can probably, this isn't absolutely necessary, but we can do this because we usually tend to think more closer to FOIL when we have less factors of that first term. And that's what we're doing here, is we can keep these first terms positive and manipulate the signs of the second terms in the binomials to fit our situation. Okay? And then try those. This last one here too, or last one in this group probably we're going to talk about, is using multiple variables. Here I get 6r squared minus 13rs minus 28s squared. Well, the reality of what this means is I have the first to consider here. What would be the factors? Well, I'm going to have an r times r to get r squared. And then the last is to get an s times s, or s squared. I have to have the last term have the variable s in it. So then the issue just becomes on what do I do for coefficients to make this inner and outer addition end up being negative 13rs. Now remember, we can change the order of these terms like this. If I end up with like 5sr, that's the same as 5rs. So we can use the commutative properties to match up our like terms. Okay. So they go through all these combinations, which there are a lot of, and then check middle terms. Nothing changes other than the amount of checking of this middle term stuff, the inner and outer, that could occur. So it can take some time. Give yourself some time to do these. I'm going to stop there, and we'll make another video on the grouping method, just to cut down the time of each one of these sections. But if you watch this first one, like if you got to this point, you probably have, and we can, I'll stop here and I'll make another video.